Hi everyone. In this video, we are going to discuss on tutorial 8 on topic center of mass. So for question 1, we read the question first. Particles of masses 0.20 kg and 0.50 kg are at the 20.0 cm and 66.0 cm marks respectively on a uniform ruler of mass 0.30 kg. So find the position of the center of mass of the system. Okay, so in this question, we imagine this is a ruler, 1 meter rule, and then the mass 0.20 kg and 0.5 kg are at the 20 centimeter. Okay, so this is 20 centimeter, and the mass of the ruler is 0.30 kilogram. So it must act at the center of the ruler because the ruler is uniform. So at about 50 here, 50 centimeter mark at the ruler. Okay, then this is about 22 mark. 20 centimeter mark here. So this is 0.20 kilogram. Okay, we put here, and then another one is at the 66 mark at the ruler. So the mass is 0.50 kg. Okay, so now we are going to find the position of the center of mass of the system. So we use the formula of center of mass. The summation or algebraic sum of the three objects here. The summation of the product of mass times x divided by summation of masses. Altogether there are 3 masses, the 2 objects and including the ruler. Okay, and then they are all at horizontal position, so we choose we just calculate for center of mass along the horizontal. Okay, then first step we choose the fixed point. So we choose the fixed point at the 0 mark here. Okay, fixed point at the 0 mark here. Okay, then measured from here for the first object is 0.20 kilogram. So the distance from the fixed point here is 20 centimeter. Okay, so we put 20 centimeter. 0.30 is at the 50 centimeter. Okay, and lastly the 0.50 kilogram is at the 66 centimeter, and then divided by total of their masses. Okay, the answer we get 52.0 centimeter. So if we imagine the from side view, this is the ruler. So we put the 0.20 kg here mass, and then 0.50 kg here, and then the 0.30 kilogram is the center of mass of the ruler itself. Okay, so if we put a what you call this fulcrum here at the 52 centimeter mark at the ruler, so both object here can be balanced. Okay, can be balanced, and the position of the ruler will be horizontal. Okay, then we go to the next question. Okay, we read the question. The figure below shows a uniform metal plate which is made up of a square of sides 20 cm and an equilateral triangle. Okay, find the position of the center of mass of the metal plate. So this is a metal plate, both made of the same type of metal, and they are uniform shape. Okay, one is a square shape, another one is a triangle shape, equilateral triangle shape. Okay, so we label the side. This is a square, so 20 centimeter each side. Equilateral triangle also 20 centimeter. All sides are the same length. Okay, using the center of mass horizontally means along x direction. So why? Because the two plate is is uh, is what you call that, is arranged side by side here, and we can see that their center of mass, each of them is at the center. So we use just axis, along x axis or horizontal position. So for mass not given in the question, so we use formula density times volume. Density is mass times volume. So mass is volume times density. Okay, so the below M also rho V. Rho is density, V is volume. Okay, then the resistivity, the density is the same, so we can cancel the density. Okay, cancel out the density, but the volume, their area, the area is not the same because one is square, one is a triangle, but the thickness is the same because they are plate. They are plate, so thickness is the same. So we can use volume, area times the thickness. H is the thickness of the plate, and the thickness is the same, so you can cancel out. So therefore, we, instead of using mass, the sum of mass times x, but we can also use the area times x. But this one is special case for the plates. Okay, for the plate. Okay, so the total of product of area times x, we can measure the x distance, okay, from a fixed point. So let's choose the fixed point here. You can choose anywhere actually, but in our discussion today, we are going to choose the fixed point here. This is where the distance will be measured from. Okay, so the center of mass for square is in the middle here, and the distance from the center of the mass square here to the fixed point. Okay, we are going to find this. So to find this x, you need to find this length of the equilateral triangle. Okay, for the side of the square, half of it is 10. Okay, 10 centimeter. So from this square, 10 centimeter, and then we know 20 centimeter, so we can use Pythagoras theorem to find the length, this length of the equilateral triangle. So square root of 20 squared minus 10 squared, we get 17.3 centimeter. So the length from the fixed point will be this 17.3 plus the 10 centimeter. Okay, so we get 27.3. So this is the distance of the square from the fixed point. So we can substitute into the equation here. Area will be 20 times 20, okay, centimeters squared. And then the distance is 27.3. Okay, then the area below here, total of area. So for square, 20 times 20 centimeters squared. So for the equilateral triangle. For the equilateral triangle, to find the center of mass, so we draw a line here from the vertex here to this side where it divide equally the distance. Then we draw another one from another vertex to this length, divide equally the length here, this side, the length of this side. And then another one, the last one, the last vertex to the other side, opposite side of this vertex. So the length divide equally. So they will all this line will intersect at one point. Okay, so the point here is the center of mass of this equilateral triangle. Okay, so we can find the distance from the fixed point to the equilateral triangle. Okay, to find this x, it is found that the center here is two-third from the fixed point here. Okay, two-third. So you can prove this using maths method, but we don't want to go into detail that one. So this one is mass knowledge you all have. Okay, so the fixed point here is found to be at two-third from the fixed point here. Okay, so 2/3 times the 17.3. Okay, the whole length here is calculated already just now, 17.3. So 2/3 from the 17.3, so you get 11.5. So that's mean the distance of the distance of the center of mass of the equilateral triangle from the fixed point is 11.5. Okay, the distance. Okay, and then the area you can use half time base times height, so of the equilateral triangle. So half times base, so the base of the equilateral triangle is 20, and then this height we calculate in the previous slide, we get 17.5. Okay, just now, so we get area is 173 centimeters squared. So we substitute into here, area times the distance 11.5, and then here the total of area. So the area of equilateral triangle is 173. Okay, so now after substitute all the values into this formula of the center of mass, so the answer is 22.5 centimeter. Okay, so from the beginning we didn't convert to meter, so all we use centimeter, so the answer also in centimeter. So 22.5 centimeter is where the line joining horizontally center of mass of the square and of the equilateral triangle is this one. So 22.5 centimeter is somewhere here. Okay, because the length here is 17 point something just now. Okay, forgot already. So that's mean a little bit in front, little bit in front, so it's 20.5. Okay, so that's the answer. That's the center of mass of the system. Okay, now we go to question 3. The figure below shows 3 particles of masses 2 kg, 0.5 kg, and 3 kg at 0.00, okay, at 0.20, and lastly at 0.22. Okay, this is the coordinate given. Find the position of the center of mass of the system. Okay, so from the diagram, for easier solution, so we just put the coordinate on each of the masses. So this one 0, 0. The coordinate for 0.5 kg is 2, 0, and the coordinate for 3 kg is 2, 2. Okay, so this time we need to find the center of mass along x and also along y, along x. So along x horizontally, so the mass times x, the x coordinate. So this one 2 times 0, okay, then 0.5 here times 2, okay, times 2 here, and then 3 times 2, okay, all the x coordinate here. So mass times x coordinate divided by total of mass, so 2 plus 3 plus 0.5. The answer is 1.27 meter. Okay, then for y, center of mass along y will be mass times y coordinate. So 2 times 0, for second one 0.5 times 0, okay, and then 3 times 2, okay, 3 times 2. Okay, then divided by total of mass, so we get center of mass along y will be 1.09. So this x, mean x, mean y actually. So from here, if we draw this on the scale, so x is 1.27, somewhere here 1.2. Okay, 1.27, and then 1.09 is somewhere here. Okay, this center here 1, 2, 3, 4, 5. Okay, 5. So 1.09 there. So this is the center of mass for the system. Okay. Okay, next we go to question 4. Okay, a particle of mass 2 meter moving with a velocity 2 meter per second collides head-on into another particle Q of mass 3m, which is stationary. So after collision, P and Q move off together. So find the velocity of center of mass. First question, one before, and then question 2 after collision. Okay, so for before collision, so we are going to find velocity of the center of mass before collision. So before collision, okay, we illustrate with diagram. The initial velocity is 2 meter per second. Okay, and the mass is 2m, and then the q has mass 3m and it's stationary, so u is 0. Okay, mass 3m, u 0. Okay, so for before collision, before they move together lah. So before collision, so we use principle of conservation of momentum here. We use principle of conservation of momentum. So before collision, for the using the center of mass, okay, um is the velocity of center of mass. We use the total of the system, the mass total of the system, so 2m plus 3m. So this is before collision, okay, before collision. So their total of mass will be 2m plus 3m. So the whole system, 2m plus 3m, and then times the velocity of the center of mass. Okay, so it's um. So um is the velocity of the center of mass. Okay, from the principle of conservation of momentum, the this will be equal to the momentum, total of momentum of each particle, p and then q. So we equate to the, okay, this one is the whole system. Okay, for the individual, for p will be 2 times 2, okay, 2 times 2, because 2m here, 2m times 2 speed or velocity, and then 3m times the uq will be 0. Okay, this one, speed is 0. So now we can solve for um. This is u for when that for separate them, the u individually, u for p, and then for q 0 here. So we can solve for um. Okay, so you get I go back. Okay, so you get the velocity of center of mass is 0.8 meter per second before they collide. Okay, before they collide. So this is the center of mass. Velocity of the center of mass, 0.8 meter per second. Okay, so now we calculate after collision. Okay, for after collision, so this is the situation. They move off together. So that's mean the center of mass also for the whole system will be total of their masses. We still use more principle of conservation of momentum. So after collision, they move together. So let's say Vm is the velocity of center of mass. So for velocity of center of mass, we use the total of mass, because for the whole system, the whole system. So that's mean 2m plus 3m times the v. Okay, this one is not center of mass. So 2m plus 3m, then times this v, because v we don't know yet. So we need to find v first before we use velocity of center of mass. So we calculate v first. So we use after collision, this move off together. So the total of mass will be 2m plus 3m times this v. Okay, before collision, they are not. One is 0. Velocity is 0. So 3m times 0. The other one will be 2 times 2, the speed. So this is before collision. So from here we can calculate v. So we get v 0.8 meter per second. So this one we use principle of conservation of momentum to find this v first. Okay, next step, we keep this v here. Okay, is 0.8. So we are going to use for the second part of calculation. We are going to find velocity of center of mass for the after collision. Okay, to find the velocity of center of mass. Okay, so we can forget about the before collision now, because we are going to concentrate on after collision. So for the whole system, they are move off together, right? So we still use the whole system, the total of masses. So 2m plus 3m times the velocity of center of mass. Okay, then after collision, this is individually, but actually they are not individually after collision, they move off together. So again, it's the same 2m plus 3m. Okay, times the V that we calculate from the previous slide. So the V that we calculate from the previous slide also 0.8. So you substitute 0.8. Okay, this is this value of V. I didn't put here just now. Okay, we calculate from the previous slide is 0.8. Okay, so this VM we calculate and we get is the same actually. Cancel out 2m plus 3m both side. So we get Vm is 0.8 also, 0.8 meter per second. So it's the same as the V, as this V, 0.8, and the velocity of center of mass also 0.8 meter per second. Okay, so that's the answer. Okay, now we go to, okay, so we finish already tutorial 8. Okay, so bye-bye.